we have a new comet coming our way? Yes, we do. That's what we're going to find out today in Buzz, Blossom, and Squeak. Hi, this is Jill from the North Woods, talking about nature and nature right outside our front door. Today we're going to talk about comets. And if you're ever wondering what a comet is, that's what it is. It's not a plane, it's not Superman, it's not a star, probably not aliens, could be aliens, but probably not. It is probably a dirty snowball from the outskirts of our solar system. It probably is a comet if it has a ball with a long streak at it. And guess what? In October of this year, another comet is coming close-ish. And it should be marginally visible with binoculars or the human eye. I'll tell you another secret is sometimes the iPhone can take a picture of it without you being able to see it very clearly. The iPhone's camera is better than our eyes. But we're going to talk about what makes a comet, what they are, and how you could go find one for your very own self. There is a quote from David Levy. Technically, a comet is a chunk of rock, ice, dust, left over from the solar system's formation. Oftentimes, they're less than 10 miles across, about the size of a small town, and they swing close enough to the sun where the sun heats them, their icy core, causing gas and dust to erupt out the backside. And then they grow their signature tail, which is actually two tails. The dust tails that you see one is the dust tail, and that is drifting off of the comet's surface. What happens is that it's way in the cool side, in the midst of our solar system, and it's cold. As it gets closer and closer to the sun, which all of these are orbiting the sun, it starts to shed material. And so that comes off of the comet's surface, the dust tail. Then there's the ion tail, and these are charged gas particles that are pushed directly away from the sun from solar wind, so it's whiffing off. And the tails always point away from the sun, but sometimes they almost look like a fork. Apart from each other. Some people on the last comet we got to see in September of 2024 saw two tails on it. So you might be able to see it depending on which angle it is and as it switches direction. Comets come from usually two neighborhoods. One is called the Kuiper Belt. It's just beyond Neptune. There's short period comets like Halley's Comet every 75 years. And then there's the Oort cloud. And the Oort cloud surrounds our solar system. It's about 50 times farther away than the Kuiper Belt. And those types of comets maybe have like 80,000 year cycles. And we might get a chance to see one of those, like I said, coming up this fall. When these are in orbit, there is a pull from our sun trying to gravitationally nudge them into passing towards the sun. And also, we mentioned one is just beyond Neptune. It has a gravitational pull. We have a gravitational pull. And these pulls just start beginning to pull some of these devices in towards us, towards the sun. They have huge elliptical orbits. One of the ways that we keep safe in our solar system is we have a Jupiter. It has a huge gravitational pull to it. So many times, as these comets and asteroids and things start floating into our neighborhood, they get sucked up and Jupiter's gravity pulls them in. That usually keeps our solar system relatively clean. It protects us from getting hit too often. And then other objects will eventually go around the sun in this huge elliptical orbit. So there was a comet called Tsu-Chin-Chan, sorry if I'm making a mess of that was noticed by an observatory system that was for planetary defense called Atlas. So that's where it gets its name, Atlas. And many of these devices get it because you name these items for what first noticed it. And so in this particular case, it was noticed by China, scientists in China, and noticed by the Atlas defense system. What was initially considered in this comet is that it had an 80,000 year orbital system. And WVU, Planetarium and Observatory, makes notes about them and noted and started doing research about it, suggesting that it's in the possibility of being ejected from our solar system. as it's going through this passage, making it really rare, like a once in a lifetime. So the observation of this comet came, like I said, from China at the Purple Mountain Observatory. It has a Chinese name, and I'm sorry, I cannot say it. Then the Asteroid Terrestrial Impact Last Alert System, ATLAS, observing these objects in South Africa. So the idea is that that's how it got its name, from these two observations. So what happened in 2024, somewhere, I think it was in October, actually, it started coming closer and closer to Earth. And it was there for about a week, where it was visible with the naked eye. You could look and they would tell you that you could see it right directly inside of a particular direction. So if you see the moons over here and you find it over here, you can see that particular asteroid. And so my friend and I went out and went to a cornfield that has absolutely no light. It's our secret Aurora comet viewing cornfield. And we go out there, and that gives us a chance to see something with near darkness. The iPhone took a great picture of it. I'll put it up here. But we captured some of the image and its tail, and even that extra tail. I did not get a good picture of the extra tail, but I did get to see a small hint of it when we were there. That, like I said, happened in August of 2024. We have another one coming this year. So that's pretty exciting. We have seen a number of these objects come through, and we see these for a number of times. We had some at the beginning of the year of 2025. Unfortunately, they're not very visible with the naked eye. If you go to like an observatory, something like that, you would be able to see it. We had a couple in 2023 as well. 2019 was a major, was another ATLAS. It was, 2019 Y1 ATLAS. ATLAS is the one that discovered it, and it was marginally visible in that spring of that year. But essentially, it gives us a chance to go and see them. But like I said, we have another one coming this year, and it's coming in October. And it's not going to be as bright as the one that came in 2024, but it may be visible in the night sky with our eyes or binoculars or using your cell phone. We'll keep our eye on the news as it gets a little bit closer. So let's talk a little bit about the magnitude of the comets that we have, because then it'll help us know if whether or not we can see it. So the magnitudes are essentially logarithmic, which means that every number is double of the number previous to it. So let's just talk about magnitude as how bright a star looks like based on its system. So the idea is that the sun is minus 26. That's the brightest thing we see. The moon full moon is minus 12.6. Venus is going to be minus 4.4. Sirius, the dog star, that's minus 1.5. And the faintest thing that we can see by the visible eye has a magnitude of 6. Telescopes, kind of the home purchased ones, you might be able to see the magnitude of 9 or 10, and you definitely need a better powered telescope in order to see 11. And in 2024, the one that came out in fall, that one had a magnitude of minus 3.8. So it was almost bright as Venus was. We still could see it, and we could still take pictures of it, which was pretty cool. This next one that's coming in late this year is going to be dimmer. It is going to be something that maybe we can't see with the naked eye, but we'll keep our eyes open just to see if people can see it. But right now, the estimates are that it's going to fly between the sun and Mars, and it's going to be too dim to see. What the estimate I saw was 12 to 13 magnitude, which is beyond what you can see with the naked eye. That one that happened last year was really cool. Like I said, we got pictures of it. I could see it. We could see it with binoculars. They thought it was going to come around the other side of the sun and show its two tails because we would have a better angle with it. And what happened is it broke up and fell into the sun. They did think that it had enough oomph to go through and actually clear the sun. It just didn't. So we'll find out if this one does. I think it's because it's farther out. It probably has a better chance of doing that. So that's how you can tell which stars, which comets you can see is based on the magnitude of light. So if we get a chance to see a comet, we're going to see, have comets happen. They do happen from time to time. None as exciting as Halley's Comet. I got a chance to see that or certainly see pictures of it when I was younger. So the best way you can go find some comets of your own is, first of all, go someplace really dark, and that means rural skies. I tend to go towards cornfields, farm fields that are way out in the country, dirt roads, country roads, that kind of thing. That's where you're going to get a good amount of darkness. So I scouted out ahead of time places that are super dark, that aren't too creepy because I don't like being out there by myself, and that are places that have good visibility, no forests or hills for a long period of time. When I went camping this year, I had some good darkness, but unfortunately I was in some very hilly areas, and then you can't see past the hills. So I like to scout out places that are good for nighttime observing ahead of time. In this last case, tended to look west. In this case, it was about a fist width away from the star Venus. I used Star Walk 2, and I used another app that my friend Allison at podfeet.com mentioned, Stellarium, a really good astronomy app as well. Bring binoculars. You got those birding ones set up, right? Bring those along, and that'll help you in order to be able to see it. Or bring your iPhone along. You can set it up so that it has its camera lens open for a longer period of time, like a 10-second exposure, and then you will be able to capture something that is not moving, according to us, very quickly, and it's really fun to get great pictures of it. But here's the thing, is that you have to know when the peak of the comet is going to be visible. Every day, it drops a little lower and lower in the night sky. That's what happened with the previous one too, and that makes it harder to see. Also, you need to find a night where the moon is either going to rise during daytime or rise late at night. That moon will just blast light, and it'll make it hard to see very dim objects. So you want to make sure that you get away from the moon being bright in the sky at the same time when you're trying to look at a very dim object. So check those moonrise times and make sure you have it. And like I said, we mentioned before that I saw Halley's Comet in 1986. Looked like a fuzzy dot, but it sure was exciting. Coming back in 2061, and this time it is expected to be brighter. That comet was first predicted to return in 1905. And people have seen it since, 240 BC. I don't know that for a fact, but that's what the records say. It is about 9 miles wide. It emits 3 tons of materials per second when it gets near the sun. And it's 80% water with some carbon monoxide, methane, ammonium, and other organic stuff. And we are getting better and better at observing comets. The European Space Agency even sent a mission to it in 1986, and it got pelted with debris, but it did send back some valuable data. And we are getting more and more impressive when it comes to missions. Rosetta was launched in 2004 by the European Space Agency, and it traveled 6.4 billion kilometers and used Mars gravity to slingshot around it, and finally was able to have a robotic probe to capture Comet 67P. There you go, in 2014. So we're just getting better and better at this. We're going to learn a lot more about comets. We're trying to understand what the material in their dust tails are. We're trying to learn what the materials on the actual comet land itself. And like I said, we are getting better and better. And just so you know, that comet, meteoroids, and asteroids are different things. Comets are ice, dust, and then they have that tail. And the orbit goes around the sun and then far away from it. The sun has a huge gravitational pull. Asteroids are rock, metal, there's no tail visible on it, and they tend to be closer to the asteroid belt, but sometimes, they can swing in. And a meteor is when we have meteor showers. We have the Leonids, we have the Perseids, and that's when we see little tiny pieces of rock enter our Earth's atmosphere. We have a gravitational pull too, and it usually burns up. When it burns up, we call them meteors, shooting stars. If it survives, then it becomes a meteorite, and people go look for them. They know where-ish it lands once it finally does hit, and you can go find the debris left by these particular pieces that come in. But where do these meteor showers come from? The Leonids, the Perseids, there's a bunch of them out there. Debris left from comets. So the comets are almost like nature's little glitter bomb, leaving these trails of debris across the sky, and then eventually we get to enjoy them as meteor showers as Earth's path cross into that. So it doesn't cross into us, we cross into it. So that makes it kind of exciting too. So all of it really has to do with comets right there from the very beginning. And with comets being sort of these cosmic time capsules, they preserve what the solar system is made up of. In old times, they have the materials that we can see. Do they have water on them? Do they have amino acids in them? People in the past have been afraid of them, thought that they brought doom, or thought that they were a sign of good things to come. And now we're looking at them with our scientific eye and getting even better at sending probes to them. So my challenge to you is, well, before October 25th-ish, go out there and see that comet if you can. Bring an app, look for a really dark place, bring binoculars, but be ahead of time. Like I said, go scout out some good places where you can see a clear horizon around you, no trees and bluffs or anything like that, mountains. Make sure it's super dark. Make sure you're allowed to go there, and make sure you're going to be safe out there, wherever it is bears are going to get you, that kind of thing. And scout it out ahead of time. Know where it's going to come, and then be prepared. So when October rolls around, you're ready to go see that. By the way, these locations, if you live in the north area, are great for seeing auroras too. It's also my favorite aurora spot. Oh, goodness. So there you go. I hope this has been helpful to you, that you might actually go out and get to see a comet. It might not be this one. Maybe it'll be the next one. You're always welcome to email me at jill@startwithsmallsteps.com. I would love to hear from you. Any other email is not going to be something that works right now. I'm having some kind of certificate problem, but jill@startwithsmallsteps.com does. Email me, leave a comment here, follow and like this, and let me know if you've seen really cool comets before too. And get out there and go see neat astronomical things.